last week to do your Wednesday, Tuesday, and Monday verses for extra credit. Next week they're due. So let's say our Wednesday verse. Blessed is the man who does not walk in the counsel of the wicked, or stand in the way of sinners, or sit in the seat of mockers. But his delight is in the law of the Lord, and on his law he meditates day and night. And he shall be like a tree planted by streams of water, which yields its fruit in his season. And his leaf also does not wither, and whatever he does prospers. Not so the wicked. They are like the chaff which the wind blows away. Therefore the wicked will not stand in the judgment, nor sinners in the assembly of the righteous. For the Lord watches over the way of the righteous, but the way of the wicked will perish. Okay, so today we are doing Lesson 45, Linear Regression. Okay, and we're doing this one little problem. Now, you have been doing them to where you had the points given to you on the page, but you really didn't do anything with the points. You looked down here on the graph, and there was the line. Okay, and the line had endpoints that were normally in a place where you could see that they were exact, and you would go in there and just take your two endpoints and you would make an equation of the line. So let's do that real quickly because that's what we've been doing, but today we're going to learn how to do it with an actual linear regression where we're going to use the points. From this point on, you will be responsible for knowing both methods. Both doing it when the line is already given to you and when you yourself have to find the line of regression. Okay, so here we go. We're going to plug these in. And so what is the slope of this line? The slope is going to be, M is going to be y2 minus y1, 10 minus 1 over y1 minus y2, 75 minus 120. So the top one's going to be 9. The bottom one's going to be 45 negative. Okay, is that correct? So negative 45, and can that reduce to what? Negative 1/5. Okay, so I can say that's negative 0.2. All right, 1/5 or 0.2. And then I'm going to do what? I'm going to plug it in. Now, they usually give you a formula here. And they give you AG equals M. And then the other one was AU plus B. Okay, that's the formula we're going to use to get this line. So now we know our slope is negative 0.2. Okay, now how do we go about getting that B? Plug in one of the points, right? So we're going to plug in one of the points, and let's just choose this one, 75, 10. So if we plug in a 75 here and we plug in a 10 here, we're going to get what? 10 equals negative 0.2, 75 plus B. Now that, I'm going to go back to negative 1/5 here because it's easier. So 5 goes into 75 how many times? 15, right? So negative 15 plus B is 10. All right, so what's the B going to be? 25. So now I've got AG is negative 0.2, AU plus 25 because I found out my B. Now that's how we did it when we had an equation, a line already given for us where we could find the endpoints, okay? Now what we're going to do is look at linear regression. So in order to look at linear regression, you're going to need your calculators. If you have a graphing calculator, you can do this type of problems. But I'm going to show you how to use the graphing calculator so that you know it in the future. Let me make sure we're still going here. All right, looks like we're still going. Okay, so now I'm going to plug these points in. To plug these points in to get the actual linear regression, we're going to go to Stat on your key. You're going to go to Stat and you're going to hit Edit. Okay, and when you hit Edit, you're going to have your L1, your L2, your L3 list here. Let me see if I can get close. Okay, can you see it? Yeah, you can see it. So I'm actually going to enter the points into L1 and L2. I'm going to enter these points up here into L1, and I'm going to enter these points down here into L2. Okay, as you can see I have already done. Okay, now I'm going to go to Stat, and I'm going to hit Calc. Stat, and move over to Calc, and then when I get down to Calc, I'm going to move down to number 4. And number 4 is linear regression. So I'm going to hit down, I'm going to go put my cursor on number 4, which says linear regression AX plus B. Okay, and then I'm going to hit enter, and then it's going to default to list 1 and list 2. All right, and I'm just going to go on down because it's defaulting where I want it to, where I stored my data, and then I'm going to go down to calculate, and I'm going to hit enter on calculate. All right, and then it's going to give me, I wonder how this is going to show up on there, but it's going to give me y is ax plus b. Okay, I'll write what's on the screen in case it shows up backwards, I don't know. Y is ax plus b. A is negative 0.2075. B is 25.64. Okay, so they got their line pretty good. Okay, they're trying to get you through the method, but to be exact, it's negative 0.2075. And this is called the least squares regression method that is built into your calculator to do this. We got a 25, we got a 0.2, negative 0.2. They did it with the points and got something very, very close. Okay, so you're going to be responsible for both of those methods in the future. Now, we're also talking about today our complex roots in lesson 46 and how to write the equation with a lead coefficient of 1 whose roots are 1 plus 2i and 1 minus 2i. Okay, so when we're doing this, let me see if we're set up here to see that problem. Okay, so now when we're doing this, we're going to say that if these are the roots, now let's think with me for a minute. Let's do something pretty simple. Let's start with x squared plus 2x plus 1 equals 0. Now that's not this equation, but let's look at it. Okay, if I were going to go about finding the roots of that equation, what steps would I go through? Would I first factor? Okay, I would factor. I'd say, okay, x plus 1 equals 0. Okay, and then I would do what? Set each factor equal to 0. Okay, so I'm going to set x plus 1 equals 0, x plus 1 equals 0. This has got a double root, and I get x is equal to negative 1, and x is equal to negative 1. So basically, what I'm doing up here is I'm doing this process here backwards. Okay, so basically, if we know the roots, then what would I do to go to this step? Isn't this x minus the root? X minus the root equals 0. Okay, so I go from the root to the factor that would contain that root. Okay, and then I go from the factor up to the polynomial, and I simplify. So we're doing this process in reverse for this problem. Okay, so what we're going to do is we're going to start with our roots. 1 plus 2i, 1 minus 2i. All right, now how would I make the factor that goes with those roots? Cleveland, how will I make the factor? Anybody?
X minus 1 plus 2y.
Very good. X minus parenthesis 1 plus 2i equals 0. X minus parenthesis 1 minus 2i equals 0. Those are the factors that go with those roots. Okay? So then what will I do? Go ahead and distribute that out. X minus 1 minus 2i. And then on this one, x minus 1 plus 2i. Put them in their parentheses equal to 0. So what would my last step be? expand, multiply those out, right? So remember, when you have something like this, it's easy to just take the first one and drive it through the whole thing, take the second one, drive it through the whole thing, and so forth. So we're going to take the first one, x, and let's go through the whole thing. What will we get? X squared minus x plus 2xi, right? And then I'm going to take the second one and drive it through. So I get a negative x, everything's just going to be negated, right? And a positive 1 and a negative 2i. Then I take the third one and I drive it all the way through. Help me. What do I get?
Negative 2x.
Negative 2x
plus
plus 2i.
minus 4i squared.
Right, minus 4i squared. What is a minus 4i squared? Plus 4. Okay, so this is going to become a plus 4. Now look at what happens to all these imaginaries. Okay, I got a 2xi. I have a negative 2xi. I have a negative 2i, and I have a positive 2i. Okay, this became a plus 4. So what is my equation that makes all of this work? I've got a x squared, right? I've got a negative x, so I've used the x squared. I got a negative x and a negative x, so negative 2x, right? And then a what? Plus 5. There is the equation with the lead coefficient of 1 that factors into the roots of, we'll give you the roots of those. 1 plus 2i, 1 minus 2i. Do you see what the process was? It was backwards on solving for the roots, wasn't it? Okay, now look at this one. It says factor this one. Now since we're in imaginary roots, do you think maybe this one has imaginary roots? Okay, so we're going to pull out a 2. We're going to factor that out, x squared plus 2x plus 4. Okay, then what would I do to continue to factor it? Does this thing look factorable? Wes?
X plus 2 squared.
Is that going to work? Is that going to factor it?
You have to go to imaginary numbers.
We're going to have to go to imaginary numbers. In other words, when something does not factor easily, we're going to go to our quadratic formula. Okay, so we're going to have what? What does our quadratic formula say?
Negative b plus or minus the square root of b squared minus 4ac all over 2a.
Excellent. Okay, negative b plus or minus the square root of b squared minus 4ac all over 2a. And what is that? That is x equals negative b. That's how you solve for the root. Okay, when you get done with your quadratic formula, you have a root. All right, so now we go what? Negative b is going to be negative 2. Negative 2 plus or minus the square root. B squared is 4. Minus 4a is 1. C is 4. All over twice a, which is 2. Okay? So now, what does this simplify to be? Can we simplify that? Negative 2 plus or minus what? Let's see if I'm seeing this. Yes.
Academic team is supposed to be study.
Okay, hold this down here. All right. So this one is going to be right. Yeah, I can see it. Okay, so this is going to.
Plus or minus square root of 2.
Okay, because this is going to be what? The 4 minus 16, right? 4 minus 16. Negative 12
Are there 2 4s here?
over 2. Okay. Now what's that going to become? Square root of negative 12. Cleveland, square root of negative 12. Selena? It is imaginary. Very good. Yes, but how would I break up 12?
2 squared of 3i.
2 square root of 3i. Very good. So we're going to have, let's go this way. Negative 2 plus or minus. That becomes a 4 and a 3. Okay, so it's going to be 2 square root of 3i over 2. All right? Yes, you may. So then this one's going to be what? Can I simplify that further? negative 1 plus or minus square root of 3i. Now, what was it they asked me to do? They asked me to factor this. Okay? They asked me to factor this. So how am I going to factor this? Okay? I think if you just stick it on the desk, you'll be okay. Okay, they asked me to factor this. So what will I have? 2 times. Can I make a factor out of that? Don't knock on my computer, Ben. Can I make a factor out of this?
Do we turn it
Would
on?
somebody get my phone?
Do we turn it on?
No, Wes. Huh? Yeah, you can turn in your homework. Everybody exit quietly, please.
We missed it.
All right? Thank you. All right. Everybody just exit the room, please. All right?
Okay.
Not everybody. So this one's going to be what? This is my root. What is my factor? It's in that first drawer. It's going to be x minus, if I use 1 plus the square root of 2, it's going to be negative 1 plus the square root of 3i, and x minus a negative 1 minus the square root of 3i. Those are your 2 factors, and when I simplify those, let's come back this way here. When I simplify those, I'm going to get 2 times, because remember I pulled out a 2 at the beginning. 2 times, and when I simplify this, it's going to be x plus 1 minus square root of 3i, and x plus 1 plus square root of 3i, as shown in your book. Okay? Let's make sure we got those right. This is example number 2, x plus 1 minus square root of 3i, x plus 1 plus square root of 3i times 2, and this is the factor of that situation. So let's recap. What did we do? We started out with this right here. Factor this polynomial. Okay, we're factoring this polynomial, so we pulled out the 2. So then we had this polynomial that wouldn't factor, so we went to the quadratic formula. And we found the roots, and the roots were right here. We found the roots of that polynomial. Then we went back, because we were told to factor, not find the roots. We went back after we found the roots, and we built the factors by saying x minus each root. And then we wrote it in a simplified form. Okay, does everybody see what we're doing? If you're told to factor something that is not going to factor evenly, you can do that. You can go to the quadratic formula, you can find the roots, and then go back and build the factors after you find the roots. X minus each root is going to be a factor. Any questions on that? Okay, so hopefully everybody saw that whole board, because that was kind of a jumble with that, okay? So, let me go ahead and close that one down.